All right, good evening class. I made you guys a model of the sliding filament theory. While there's a lot on here, uh, most of it you won't actually have to put onto your model, right? So we started with a very simple drawing of a muscle, okay? And within a muscle, we break down into multiple different systems within the muscle itself. So really the only thing that we need to worry about right here is this very last one here called the muscle fiber, right? And the myofibril comes out of a muscle fiber, and you can see there's multiple ones in there, right? And then over here, this little part right here is this, okay? This is what's going on inside of a myofibril, right? That's an important part of a muscle. And then, as you can see here, the red and blue lines are actually broken up even more into this larger piece of this diagram here, right? So there's multiple parts that we need to be concerned with, right? And then also we need to be concerned with how muscle moves, right? And the way that muscle moves is through an alpha motor neuron, which is basically a neuron, gets activated, right, to do some kind of muscular work, and it sends a signal to this myofibril here, right? And from the motor neuron, you have acetylcholine gets released into the myofibril, right? And when that gets released, we release calcium, okay, inside these things called T-tubules, right? And T-tubules are here, and they're basically a T shape. That's why they call them that. They're also known as transverse tubules. So these transverse tubules carry that calcium into what we call the sarcoplasmic reticulum, right? That sarcoplasmic reticulum then bathes the myofibrils in calcium. And that calcium is very important, and that's when we get into this piece over here. So there's three proteins all bound together here, and they're tropomyosin, actin, and troponin, right? Those three pieces work together, right? So that calcium that we just talked about that's in the sarcoplasmic reticulum is important because we want to move this tropomyosin out of the way of what we call binding sites, right? So that these globular heads on myosin can bind and then pull this whole structure together. That's why, as you can see, they overlap each other, and that's how muscle contracts, because that's all muscle can do. The only one action muscle can do is to contract, right? So that's how we contract. It's a rather simple model. I know that there's a lot written on here, but this is what I want you guys to draw, and mostly it's this piece here. So I'm going to send you a list as well of the things that need to be included in your model, and there is multiple things online. You know how we looked through and saw pictures of it online, right? And then I'm also going to write down what I just said to you guys, right, about how muscle moves. It's a very simple process. Obviously, from this drawing, you can see it can get very complex, because even in here, there's a bunch of different layers of connective tissue that holds all our muscle together. And then if we went even further back, we'd have tendons and bone and all that kind of stuff. But we're really only concerned with the action of a single myofibril, right? And as you can see again, that myofibril is part of a much larger system. All right, and so I would take the opportunity to kind of freeze frame this if you want. Sorry about my handwriting. It should be pretty simple for you guys to dictate this back to me, and if you have any questions about how certain stuff works, please let me know, and then I'll just go through a couple of things one more time. So we also have titin. I want to talk about that for a second. Right, titin is a skeletal structure for our whole system here, for this myofibril. It holds the myosin right where it is. So then you also have this thing called an M line here. I don't believe that's part of your model, but you need to kind of put it there. The Z discs, right? And these are Z discs here. They're rather simple structures. They're all made of proteins and fibers. And it's a system not very unlike hairs in a way, or fibers on a rope, right? And that's where we get our strength from. Again, any questions you guys have about this system and how it works, please don't hesitate to email me, reach out to me, and I can give you a really quick explanation of pretty much anything here. So go ahead, make this same exact model. Again, I'm gonna send you a list of all the stuff that needs to be included in the model. A lot of this stuff doesn't need to be included. I wouldn't worry about it. Obviously, if you want to get ahead of the game, you kind of want to know this kind of stuff. Just go ahead and look up those things. And I hope you're all having a good night, and we'll see you tomorrow for our next Zoom meeting, where we will go over glycolysis, anaerobic glycolysis, and aerobic glycolysis. Don't worry about this, won't be due tomorrow. We'll put it due next Friday. It took me a while to get everything ready to have this whiteboard up for you guys. And again, any questions, please just email me. Thanks. Have a good night.